Click the bell icon to get latest videos from Ekeeda.
Hello students. So after covering these 7 problems, let's start with the next problem on inverse hyperbolic function. So here we have different results to prove and we have to use the formula of trigonometry as well as the inverse hyperbolic function to get the results. So here tan of pi by 4 plus iv is given as r into e to the power I theta, and we have to prove 3 results. So guys, let's take one result at a time. So we'll first prove r equal to 1. Now how to do that? So if you observe carefully, then we have complex numbers on two sides. So here this is a complex number which is in exponential form, and this too is a complex number. So what we'll do is we'll expand both sides, so we'll get two complex numbers on two sides, and then we'll compare it, the real part with the real part and the imaginary part with the imaginary part, and that will give us the solution. So let's start. So I'm starting with tan of pi by 4 plus iv. Now guys, if you are thinking that we will apply the formula of tan of a plus b, which is tan a plus tan b upon 1 minus tan a into tan b, then you are absolutely wrong. Because if I apply that formula, then we will not get real part and imaginary part separately, or we will get it with complex terms. So what we have to do is we have to use a different approach. So here I will substitute this tan as sine upon cos. So here I'll say now guys, what we'll do is we'll do the rationalization over here. So since here we have the positive term, we'll multiply this with the negative term. So here I'll say cos of pi by 4 minus iv. So I'll multiply the numerator with the same term. So we'll get cos of pi by 4 minus iv. Now guys, what we'll do is we'll multiply the numerator as well as the denominator by 2. Now by doing this, what happened is we got the D Factorization formula in the numerator as well as in the denominator. So if you observe the numerator, here we got 2 sine a. Let's say if I assume this as a, so we got 2 sine a into cos b. Similarly, here we got 2 cos a into cos b. So here we can apply the formula of D factorization to get the solution. So by the formula of D factorization, here this will give us sine a plus b plus sine a minus b. So guys, here I'll say sine of, now we have assumed this as a and this as b. So a plus b, it means addition of these two terms. So if I add these two terms, so pi by 4 and pi by 4 will be pi by 2. And this iv and minus iv will be cancelled. Plus sine of a minus b. So it means we have to subtract these two angles. So if we subtract these two angles, pi by 4 and pi by 4 will be cancelled and we will get 2iv. In the denominator, we have 2 cos a into cos b. So I have assumed this as a and this as b. So 2 cos a into cos b is cos a plus b plus cos a minus b. So by doing that, we'll get cos of this plus this, which is pi by 2, plus cos of this minus this, which is 2iv. Now guys, let's substitute the values. So we know that sine of pi by 2 is 1, cos of pi by 2 is 0. Then sine of 2iv is I, hyperbolic sine of 2v, and cos of 2iv is hyperbolic cos of 2v. So let's substitute these values. Now we'll divide the numerator separately with hyperbolic cos of 2v, so that we'll get the real part and the imaginary part. So guys, here we got the expansion for tan of pi by 4 plus iv. But if you observe the question, then here the value of tan of pi by 4 plus iv is r into e to the power I theta. So we'll put that value over here. So here I'll say it is r into e to the power I theta, which is cos theta plus I sin theta. So I've converted the exponential form to the polar form, and the right hand side is same. Now we'll compare the real part with the real part and the imaginary part with the imaginary part. So here I'll say comparing real and imaginary part on both sides. So we'll get r cos theta, which is real part, which is equal to 1 upon hyperbolic cos 2v, and r sin theta as hyperbolic sin 2v upon hyperbolic cos 2v. So guys, here we got two results. Now let's start with the deduction. So first of all, we have to prove that r equal to 1. So what we'll do is, here we have to apply a formula in which this theta will be eliminated and we'll just get the r. So for that, I'll do the squaring and adding. So I'll square the first equation, I'll square the second equation, and after squaring both equations, we'll add it. So here we'll get r square cos square theta plus r square sin square theta. So I can say that r square in bracket cos square theta plus sin square theta equal to, here also I'll do squaring and adding. So we'll get 1 upon hyperbolic cos square 2v and hyperbolic sin square 2v upon hyperbolic cos square 2v. So by adding, we'll get hyperbolic cos square 2v common. In the numerator, we'll get 1 plus hyperbolic sin square 2v. Now guys, the value of 1 plus hyperbolic sin square 2v is hyperbolic cos square 2v. So that will be cancelled with the denominator and we will get 1. So it means we are getting left hand side equal to 1. Also, cos square theta plus sin square theta is 1. So it means we are getting r square equal to 1. And if we take the square root on both sides, then r is equal to 1. So here we got the first result. So we have proved that r is equal to 1. Now the second result is tan theta is equal to hyperbolic sine of 2v. Now guys, let's observe these two equations once again. So if I want tan theta, then I have to divide this second equation with the first equation. So by that, r and r will be cancelled and sin theta upon cos theta will be tan theta. So we'll do that. So therefore, tan theta equal to, so we are dividing the second equation with the first equation. Now if I divide this right hand side with this right hand side, then we'll get now guys, we'll cancel the denominator. By cancelling it, we'll get hyperbolic sine of 2v, and you can see that we got the second result. So here we have proved that tan theta is equal to hyperbolic sine of 2v. Now guys, let's move ahead for the third result. So here we have to prove that hyperbolic tan v is equal to tan of theta by 2. So what you have to observe is the angle. Now here angle is theta upon 2. So till second deduction we were dealing with angle theta, and now we have to reduce it to the theta upon 2. So what we'll do is we'll start with the result which we have derived in the second step. So from this result we'll derive the third result. So what we'll do is, from the second result, I'll take this hyperbolic sine on the other side. So that will become hyperbolic sine inverse of tan theta, and that will be 2v. So we'll start with that. Now guys, here we'll apply the formula of inverse hyperbolic function. So by that formula, we will get log of tan theta plus under root 1 plus tan square theta. Next, 1 plus tan square theta is cot square theta and root of that is cot theta. So we'll get log of tan theta plus, now 1 plus tan square theta is sec square theta and the root of sec square theta is sec theta. So here we'll get sec theta. Now guys, what we have to do is we have to solve this trigonometric function in such a way that this angle theta should get converted to theta upon 2, because in the result we want theta upon 2. So what I'll do here is, first of all, I'll substitute tan theta as sine upon cos and sec as 1 upon cos. So cos is common in the denominator. So we can say it is log of 1 plus sine theta upon cos theta. So this is the maximum possible solution. Now what we'll do is, from here we'll try to convert that theta into theta upon 2. So guys, can you tell me a formula for 1 plus sine theta in terms of theta upon 2 and the formula for cos theta in terms of theta upon 2? So if you have done the trigonometry very well, then you must be knowing the formula. If you don't know, then don't worry, I'll tell you the formula. So the formula for 1 plus sine theta is cos theta upon 2 plus sine theta upon 2 the whole bracket square, and for cos theta it is cos square theta upon 2 minus sine square theta upon 2. So let's write it down. So guys, by substituting this formulae, we got the angle theta upon 2. Now it's very easy to get the result. So to get that result, we'll cancel few terms. So here, as we know that here it is square. So by squaring, we can say that we'll get two different brackets, which is cos theta upon 2 plus sine theta upon 2 and cos theta upon 2 into sine theta upon 2. So these are the two brackets which are the similar brackets, and in the denominator I can use the identity a square minus b square, by which we'll get a plus b into a minus b. So that will be cos theta upon 2 plus sine theta upon 2, and in the second bracket cos theta upon 2 minus sine theta upon 2. So what I'll do is I will cancel one bracket from numerator as well as from the denominator, because both terms have cos theta upon 2 plus sine theta upon 2 common. So what will remain? So here we'll get log of cos theta upon 2 plus sine theta upon 2 in the numerator and cos theta upon 2 minus sine theta upon 2 in the denominator. Now guys, let's observe the question again. So in this question, we have to prove that hyperbolic tan v is equal to tan theta upon 2. It means from that answer, we want tan theta upon 2. Now what we got here? Here we got 2v as log of cos theta by 2 plus sine theta by 2 whole upon cos theta by 2 minus sine theta by 2. Now my work will be to convert this sine and cos in terms of tan. So to get tan, what I'll do is I'll divide numerator and denominator by cos theta upon 2. So here we'll get log of, so if I divide this first term with cos theta upon 2, we'll get 1. If I divide this sine theta upon 2 by cos theta upon 2, we'll get tan theta upon 2. So guys, see here we are getting the tan term over here. Next, in the denominator, divide first term by cos theta upon 2, we'll get 1. Divide second term by cos theta upon 2, we'll get tan theta by 2. Now, here it's a formula of trigonometry, which is tan of pi by 4 plus theta by 2, which is equal to 2v. Now guys, if you're thinking like this, then that's wrong, because if we'll do that, then we'll get tan of pi by 4 plus theta by 2 on the right hand side. But if you see the result, then we just want tan of theta by 2. So what we'll do is, here at this step, I will shift this 2 on the right hand side. So by doing that, we will get v equal to 1 upon 2 log of 1 plus tan theta upon 2 upon 1 minus tan theta upon 2. Now guys, if you observe this formula carefully, this step carefully, then it will remind you about one formula of inverse hyperbolic function. Now what is that formula? So here I'll write it down for you. So hyperbolic tan inverse of x is always given by half log of 1 plus x upon 1 minus x. Now guys, if you see, then here x is tan theta by 2. And here we got the same terms. So we can say that this value is equal to hyperbolic tan inverse of x, and x is tan of theta by 2. So we got value of v as hyperbolic tan inverse of tan theta by 2. Now what I'll do is, I'll shift this hyperbolic tan inverse on the other side. So that will become hyperbolic tan of v, and that will be equal to tan theta by 2. And guys, this is what the required answer. So here we have proved the third result, and I'm sure you understood why not to use this formula over here, because it's a very common formula and many engineering students make the same mistake by taking this formula over here. So you don't have to take this formula, and you have to take the formula of inverse hyperbolic function to get the right answer. So guys, now you have to do two things. One, share this video with your friends, because this problem is very difficult problem, and if you share this with your friends, then they will also understand how to solve this problem in correct manner. And second thing is, subscribe to Ekeeda channel, because here we are creating more videos for you, and you can get updates of new videos if you press on bell icon. Thank you very much.